One day humanity may settle countless worlds, but could any nation hope to govern multiple planets or even star systems? Most of us grew up on classic space opera science fiction where multi-planetary empires are a staple of the genre, and usually it's a sprawling empire composed of many hundreds or even thousands of worlds spread over the galaxy. Often these are all connected by warp-capable ships or wormholes or jump gates or some other means of FTL, faster-than-light travel and communication. We'll discuss those today too, but as channel regulars know, we're not very optimistic about FTL ever happening. Most examples of theoretically possible FTL that we hear of in science are more accurately described as situations where we are pretty sure the method is impossible but haven't been able to prove beyond any reasonable doubt that it is, rather than there being any actual evidence it could be done. I'm a physicist and I don't think so, and I don't know any colleagues who do, but most of us would love to be proven wrong. Your default warp drive runs on negative matter, so do staple wormholes, and that's material allowed under math but for which there is no evidence that it exists, and no real expectation it does either, much as we don't expect to find a negative dollar bill or a negative gallon of water outside any accounting chart or spreadsheet. We could be wrong, but if we're not, does that spell the end of our dreams of empires of many worlds? The good news is no, and we'll cover several cases today, but let's start with that classic flaw of space opera. First, our galaxy has something like 500 billion stars in it, and most will have planets that are at least as terraformable as Mars or Venus. Sci-fi writers are often horrible at scale, and even writers known for their scientific accuracy like Isaac Asimov tended to really lowball the number of planets and population we expected in a settled and FTL-capable galaxy. Both Asimov's Foundation series and Frank Herbert's Dune, two of the most influential sci-fi series out there, both have a human empire of a few million worlds at most. To their credit, we didn't know how many stars were in the galaxy at the time, as only the brightest stars could be seen, and most are a lot dimmer than our sun. So we also didn't have much expectation about how often an Earth-like habitable planet in the Goldilocks zone would exist, but even using the estimates from their era, they should have come up with more like 1 billion worlds instead. That number is fairly vital to Drake's equation and SETI, the search for extraterrestrial intelligence, as it gives us the number of low-hanging fruit worlds where complex life might emerge on its own, or where we might be able to settle without vast effort, or some of the higher tech and more inventive approaches to settling planets we've developed since then. We don't know what that number is yet, partially because we don't know how to define it. We cannot give a precise estimate of how likely a star is to have a planet with 80% or 90% or 101% of Earth's mass. But even if we did, we don't know how close to Earth's gravity and composition a planet would need to be for comfortable and easy terraforming, or to have complex native life. The number of Earth-like planets around such stars obviously varies. If 80% of Earth's mass is good enough, that's a huge difference than if even 101% is too much and 99% not enough. There's also that question of how close to their star they need to be, and we cannot assume Venus's orbit is too hot just because the Venus we know is a molten nightmare. Venus's weirdly long and backward day is likely the result of a huge collision, not its proximity to the Sun, and it's thought that this is the prime factor in its horrible conditions. Meanwhile, a planet decently more massive than Earth, out at Mars distance, might be habitable too. The most conservative calculation I've seen on the matter in recent years was 300 million from Steve Bryson's team at NASA Ames, and that was their conservative figure of assuming only 7% of the 4 billion most sun-like stars in this galaxy would have the right planets in the right location. Their high-end figure was 10 billion. This estimate is more generous with which stars to include and what percentage would have good planets. Time will tell which end of that range reality landed at, though I would tend to say for colonization purposes that value was still very low. Higher technology always helps, but the most powerful colonization tool in our current kits is to scatter either shades or mirrors at a planet's L1 or L2 Lagrange point, or an orbit of that planet or moon, to add or subtract sunlight reaching that planet, or to get more terrestrial day-night cycles of 24 hours. We discussed that option on many occasions, most recently in our episodes on statites and lagites in January, or the Lagrange point settlement episode from later that month. And the simple reality is building and maintaining one is no small feat. but vastly smaller and easier than sending off a colonial arc ship to another star or terraforming a planet, or even para-terraforming a planet with domes. That basically widens your Goldilocks zone to anything as close to the Sun as Mercury out to further than Saturn, and renders the type of star a lot less important, since that same approach can provide magnetic shielding from coronal mass ejections and other atmospheric stripping processes, as well as adjust the spectra of light to filter into something more preferable. Such being the case, rather than having maybe 1 in 100 stars be suitable for life, and maybe finding a decent planet around 1 in 100 of them, we would expect at least 1 in 10 stars, and probably better than 50-50, able to provide at least one decent planet to at least para-terraform, meaning we expect something on order of 100 billion habitable systems. But even that 1 in 100 stars with 1 in 100 having a good planet would still imply 40 million prime planets being available in the galaxy, and that tends to be our classic space opera setup, with an assumption many belong to some alien empire, or you're only in part of the galaxy, or that some worlds are lost. What it also means is that if you've got a star kingdom of a dozen planets, they might all be in the same star system. But more importantly, there are 60,000 stars within 100 light-years of Earth, and if only 1 in 10,000 were habitable, that means you've only got around 6 systems with 1 planet we could colonize that could get a signal to us in under a century. Alternatively, most of those 60,000 stars probably have multiple planets that we could at least pay or terraform, and you might easily be able to get an empire of a million worlds stuffed into that volume, which itself isn't even a millionth of the galaxy's total value. It also means you can be getting dozens if not hundreds of planets within several light-years of Earth. And that's all without factoring in artificial habitats like O'Neill cylinders, or including minor and dwarf planets in the count, or rogue planets between systems. Now, we can debate if it is plausible to have an empire stretched out over several light years, and we'll return to that point, but let's get 4 caveats in right from the outset. First, as mentioned, there are a ton more worlds to consider when we start including larger moons, big or minor planets, artificial habitats, and interstellar rogue planets. Most science fiction settings tend to act like an entire settled planet is one small county or modest city anyway, and that most star empires of a million worlds from space opera act like they've got maybe a couple hundred actual planets. Given that, I think it makes it worth noting that you could have such large empires packed into just a handful of light years. Which brings up the second caveat, that an awful lot of places have stars far more closely packed than our area does. Even ignoring places like the Galactic core, where you might pack thousands of stars into a volume smaller than the ones surrounding us before you get to Alpha Centauri, we have lots of star clusters where you might have hundreds or thousands of stars within a dozen light-years of each other, each home to several planets. And there are thousands of clusters like that, and plenty more places where stars are packed a lot tighter than here, or looser for that matter. Third, any place that has ships able to move back and forth between star systems, even just at modest sublight speeds, also could set up shop on objects too far from the sun to be running on a solar economy. Perhaps they've mastered cheap and abundant fusion, in which case every dwarf planet or icy body of note in their outer system, be it their Kuiper belt or even Oort cloud, should end up with some sort of outpost on it. Maybe it's one lone rotating habitat orbiting the snowball or buried under the ice there, home to just a few thousand folks, but it could easily be millions. That's many millions of such communities out on the fringe of most systems. Those outskirts will be much closer and denser, if generally smaller in quantity, around most planets, as most of them are red dwarfs, with somewhere between half and a tenth of our Sun's mass. Planets and outer bodies can pack in much closer on such systems, while bigger stars might easily have a dozen planets in their normal habitable zone. Now, I did specifically title this episode Multi-Planetary Empires, and on this channel, we limit that to meaning big planets, Earth, Mars, gas giants, and so on, while we tend to use the term world to refer to settled moons, bigger asteroids and minor planets, or large habitation megastructures, in addition to Earth-like planets. So we'll be focusing on actual planets in the remainder of the discussion, but that does not mean we have a future in which those other smaller but far more numerous minor worlds are non-existent, or even big players. Indeed, odds are good that by sheer quantity, they'll hold the vast majority of humans. They just wouldn't tend to be the highlights on the map, so to speak. It also has to do with the continuity of empires over big distances. we tend to talk about the difficulty of maintaining contact and control on some colony at Alpha Centauri or Tau Ceti, and how difficult that would be, and how it would take years to get help to them in event of a major disaster or rebellion. But beyond it being unlikely a whole planet would rebel out of the blue or suffer any planet-wide disaster, a planet is not a star system. In Larry Niven and Jerry Pournelle's classic novel The Mote in God's Eye, we visit the New Caledonia system, which contains two major planets, New Ireland and New Scotland. The system is a local interstellar capital of that region of humanity's current empire, the second one of note, and when the first empire fell into civil war that nuked Earth into oblivion, one of the planets remained loyal while the other rebelled, and the two fought over it for a long time. It is not hard to imagine a planet around a distant star rebelling or seceding from its capital, especially when that capital might be tens of years of travel or even communication time away, and the same for any neighbors. It's a bit different if you have a colonized solar system of several different major planets and tons of lesser worlds orbiting that star, and many more in the depths of interstellar space scattered every few light years. There is no compelling reason to assume all those planets got settled by the same group of colonists, or even that any single planet did. Let's say tomorrow a few thousand interstellar arc ships magically dropped into our hands, along with a few space towers to move people back and forth to them easily. Each ship can hold 10,000 people and happens to have a nice star chart with entries for every local star and planet of note. This is a thought experiment, so we don't care how we got the ships, as we're really just trying to look at this from the perspective of our civilization a couple centuries down the road, with better automation for ship construction and improved space capability. I have no idea how we would divide those ships up. Maybe one for each country, then divide the rest proportionally by population, or some subtly veiled equivalent to military muscle. But there's no reason to send each of those ships to a different solar system, or why a country with, say, 5 ships would send them all to one system with 5 planets, or even that a planet with 5 decent continents might not get 5 ships from 5 separate but reasonably friendly countries sending folks. Or that some country back here with a few ships but little interest in space might not sell the ships or some of their passenger slots to countries or groups or individuals. Iceland, population 373,000, might end up with a ship but have no interest in trying to come up with 10,000 citizens to load, and might sell it to the US or Canada, or keep it but only send a contingent of a few hundred and an appointed governor, while selling off slots of 100 people or less to various other groups. There is a galaxy of billions of planets out there, but they can all be colonized eventually, and in the meantime those closest are best, and some better than others, and one small continent of an Earth-like planet is probably more prized early on than an entire planet like Mercury or moon like Ganymede. And of course, once the ship gets to the destination, it can turn back around, return to Earth, and grab more people to go there or to another colony planet further away. Point being, of the 131 stars, brown dwarfs, and subdwarfs currently identified within 20 light-years of Earth that could be thought of as our neighbors on a border, nobody is likely to be in a position to casually claim the entirety of one of them, and in a way that can stick for the several centuries that would be needed for them to grow their own numbers up to something that might colonize that system rather than some small bit of it. We might see things negotiated or fought out, of course, but it's a lot more likely we would see several settlements scattered across the system, and those may or may not have any shared history, culture, or early government with each other. Nor are the mighty nations of Earth, who all share just one planet, going to be very sympathetic to colonies complaining that someone else set up shop on another continent, let alone another planet in the system. Even if they did, let's say the US in a few centuries sent a colonial fleet to a system that planted several colonies there on various worlds. What odds those all have the same grievances or issues with Earth centuries down the road? Why would all agree to band together and flat out leave? Why not one of them, or maybe a few, or maybe one doesn't rebel from Earth, but just the US and joins Japan or France instead? And what is the grievance? Probably they were not built with any intent of seriously taxing them down the road, and they probably rely on Earth for new data, science, and entertainment. The harder it is to send troops to some place, the lower the expectation you can get taxes out of them, and the harder it would be to guarantee a certain level of trade, though new settlements do tend to have strong trade relations with the country their settlers came from due to similar language and cultural norms, all of which will probably fade through time. But the default downfall of big galactic empires in a no FTL situation isn't how far away the entire civilization is, but how far away its neighbors are. If you've got 100 settled planets within a few light years of you, several of which are within light hours, you not only have a reason for trade and relations, but a real concern that even if your homeworld or central capital does not send troops, if you rebel, one of your neighbors might instead. This hardly means maintaining a multi-planetary empire is easy, but it does mean it has some things working in its favor against the overwhelming vastness of space and time. We also tend to assume colonization of other stars takes place because we're growing and looking for elbow room, albeit probably not with great urgency, as we're not likely to see super huge families become the norm again anytime soon, so we sort of trickle out into space, but that dynamic shifts a bit if we get radical life extension. All of a sudden you can have kids when you're 100 or 200, and aren't in a rush to start a family, but also have no cap on when you have to finish adding to one. That sort of shift is likely to see a rise in growth rates and with an intent to longer-term solutions. And if you don't have an expiration date, you can contemplate getting on board an ARC ship for a few decades much more easily. Particularly since you might do it while frozen if you don't want to be awake, as generally speaking the technology needed to restore someone from cryo is similar or even slightly more advanced than what you would need to turn back the aging clock. All of that is debatable of course, but tends to strike me as our most plausible scenario for the future, by plurality if not majority, assuming AGI doesn't just murder us off to replace us, and in either case you have a civilization where folks with no real cap on their longevity are trying to settle space. I'd make the case that folks who live for centuries are probably going to be at least a little more willing to consider being part of an interstellar nation when many of the original colonists come from Earth and are still alive and kicking and probably very influential there. And the same back on Earth, where a lot of your senior leadership, no pun intended, probably have siblings or children still alive and off on those colonies who they keep in loose contact with. And you still have that issue of not being able to casually rebel when several of your neighbors can get fleets over to your planet quickly. And it isn't like you could organize a planet-wide rebellion quickly or quietly either, not unless your planet was so sparsely populated that it only had maybe 1 million people on it tops, and then you really do have to worry that Earth, or your local sector capital, can't be sending armadas with more troops in them than you have people. You do still have the problem of time lag for a representative style of government. If we imagine a cluster of space with 500 major worlds jammed into a 10 light-year radius, if that's evenly distributed, then not only do some folks have a 10-year communication lag to hear about what happened back at the capital, assuming it's actually at the center, but the median delay is 8 years. 250 of your 500 worlds are 8 or more light years away, since over half of the volume of a sphere, 10 light years in radius, is in that last 2 exterior light years, while only 1/8 of the volume and stars are in that 5 light year sphere stretching halfway out. Keep that in mind as it tends to imply a rising limit. If you find out that statistically your rate of rebellion or succession attempts tends to rise linear to your distance from the capital, so that about one of those 250 outer worlds was rebelling every year, then if you double the diameter of your imperial blob, your new outer half at 16 to 20 light years out contains 8 times as many worlds who are each twice as likely to jump ship. So you're putting more like a score of rebellions down a year now, not one, and while you've got 8 times as many worlds supplying ships and troops, they are taking longer to get to each hotspot and coordinate orders. But they probably are not coming from your homeworld. These are actual planets which might have several garrisons and fleets each, even when underdeveloped, and probably none are thinking about going their own way seriously until they have hundreds of millions of folks and feel like they can be supporting their own navy to fend off neighbors. It is probably worth noting that in a lot of futuristic contexts, taxes aren't exactly redundant, but aren't really your motivation for control either. Even nowadays, most countries are not really looking to add territory by conquest and people to increase your taxes because you generally spend almost all of those on services and infrastructure for those folks. In a post-scarcity civilization or a near equivalent, while raw materials for the long term interest you still, your citizens probably aren't really super motivated about adding one more golden back scratcher to their collection by taxing the miners of some godforsaken rock harder. Those miners on that rock probably have considerably more luxurious lives than we do nowadays, even on some distant barely settled colony. Rather, your motivation is probably simply more control of those around you. That might be entirely despotic, or it might be something more democratic, where colony planets are viewed as dangerous in isolation, where some crackpot group or underregulated researcher might be playing with brainwashing viruses or rogue self-replicating AI. If your region of space just suffered a hegemonizing swarm attack from some reckless colony, they might decide their new motto for fledgling planets should be "Welcome to the Empire," or else. It obviously is not hard to imagine classic space empire tyrannies, and I do not want to just cheerfully handwave that option away, as there's nothing inherent to technology and prosperity that makes despots vastly less likely to pop up. They also have some impressive technologies available, potentially like a brainwashing virus they can unleash, or any of the sheer brute force megaweapons we've discussed over the years. Your maximum empire radius might be built around how much time lag our colony needs between them and your megaweapon to pull off a rebellion, rebuild, and build a defense to outlast it, or a megaweapon of their own for reciprocity. You might not be willing to build copies of that doomsday device away from your capital, where rebel generals might decide they would like to be lords of a smaller star kingdom of their own. And they can choose which way to point that space cannon you built them. Things get easier with FTL, of course. We'll be looking at Stargates and similar FTL 2 weeks from now, and we'll deep dive that effect on our civilization more then, but it makes a modern form of government viable again. Whereas a planet 10 light years from Earth electing a senator then presumably has to ship that person to Earth, which is likely to take more than 10 years, and so you need to start imagining some very long terms, even compared to the longevity in office most US senators tend to have, 10 of them having served over 40 years, but then again life extension technology might add to that a lot, or encourage term limits. I can't really imagine a planet feeling that their representative dispatched the capital decades ago and receiving orders a decade old is really serving their interests all that well. And 10 light years is not a big size for an interstellar empire, and a quarter of light speed would be a respectable rate of travel for a ship, so that would be a 50-year lag from the day they got elected to when they sent back their first report. 50 years ago, the senators from my state of Ohio were former astronaut John Glenn and Bob Taft No. 2, not to be confused with Bob Taft I, who was also our senator, or Bob Taft III, Ohio's governor 20 years back. It is not terribly uncommon for kids of politicians to go into politics either and end up holding their parents' seat one day, but it would be a bit amusing if we imagined a multi-planetary empire that didn't have life extension or cryo, and again the latter strongly implies the former, and send its politicians off in a generational ark ship back to Earth, or opted for some type of elaborate cloning or duplication. We saw that in the Foundation TV series with Emperor Cleon, one of the few innovations that wasn't in the book that I actually liked. And that raises the notion of aristocracy or monarchies too, and they don't seem particularly favored or disfavored at the multi-planetary level. I could imagine a loose confederacy of wars that wasn't much more than a trade and defense arrangement having legal counsel and lobbies back on Earth, with some firms known for their longevity and stability. There is a law firm out of Kent in the UK that's been in continuous operation since 1570, almost half a millennium ago, and we might see folks skipping on democratic representatives in favor of some group like that, which they can just send dated and general instructions to, and otherwise represents their interests. Or they may use some sort of AI as their representative or spokesperson, or use a brainwashing virus on someone elected to be that spokesperson to ensure loyalty. Ultimately, I can make a case for just about any system of government working. It's just an uphill effort in the absence of FTL, and some types might have a harder lift operating and justifying their existence. And even tyrants typically need to convince their lieutenants and viceroys they should stick with them rather than becoming their own sovereign power or join another team. We should also note that while some methods of governance or economics probably objectively work better than others, post-scarcity civilizations can probably get away with running systems they like better simply because their sheer abundance permits a lot of waste and abuse without breaking the wheels. For any nation to exist, rather than be a collection of smaller states, it must serve a purpose, and by default that tends to be shared defense. And in this maximum range sort of context, whatever range allows meaningful shared military support is also one in which shared defense is plausible. If an ally can't support me usefully 10 light years away, then an enemy has the same sorts of constraints to invade me. The same would apply for trade. No mutual arrangements, regulations, or treaties serve a point if distance is too far to allow regular trade. Those can be stretched out for vital things, so a treaty banning the development of some self-replicating murder machines might be in place, or some agreement to a galactic standard for weights and measures, and interstellar language or time and date is plausible too. Likely as not, there would be a host of people speaking a variety of different native tongues that were automatically translated into some standard language nobody other than computers and interstellar lawyers actually spoke, then translated into the recipient's language. Or everyone uses Earth time and keeps doing it even though Earth itself manually adjusted its orbit to exactly 365 days. There is also no guarantee every planet in each system would be part of that same empire, which may or may not have assets in other star systems too. It wouldn't be hard to imagine in the year 4000 AD that Sweden still had the same borders as nowadays, but also had 100 major asteroid colonies, modest chunks of territory on Mars and Venus, one of the moons of Neptune, a dozen major Oort cloud colonies, and was the patron and de jure ruler of a dozen planets scattered around some of the nearer stars. Same, the King of England is still king of a lot of various countries with their own parliaments, and who do not turn to him for much guidance, and that post may still exist for ages to come and could easily have millions of planets out there who sincerely view themselves as members of that realm, so long as nobody wearing that crown or over at number 10 Downing Street tries to send them any orders. Throw in FTL and the game shifts a lot, and it's also not hard to imagine most of the galaxy getting settled before someone back here in the core wards finally figures out FTL. That's a common enough plot, early colonization done by slowboats, and them getting caught up on by faster ships invented back home during their slow voyage. If that happened, somebody might decide to launch a great crusade to reunite all of humanity into one big happy family, or else. And you also have to consider scenarios like multi-planetary empires literally being physically linked by site-to-site transporters or wormholes, or just vacuum trains running on active support tethers and moving at hundreds of kilometers per second. Peter Hamilton has worked with this concept in quite a few of his novels. Night's Dawn and the Commonwealth Saga in particular come to mind, and we encounter it in Larry Niven's Known Space and Ringworld setting too, and many others. You might even build or move planets into a shared solar system to cut down on lag times and clear that space around the vacated star for intense star lifting and disassembly. As to what qualifies, it would probably be whatever the minimum was, because somebody will declare they are one as soon as they can make a decent claim on it, and that will probably stick. But I think you would need to do a bit better than being one of our larger modern nations with a large base on the Moon and Mars. Nonetheless, I would imagine the first of each of these will probably be just a handful of centuries down the road, and with several of them basing themselves off Earth, and only controlling a modest fraction of a handful of other planets, moons, and major asteroids in the solar system. I'd bet on at least half a dozen such entities that had large holdings not just on Earth, but Mars and the Moon. I tend to think that places that control the entirety of not just one system, but several nearby it, are more likely to first emerge in small star clusters we settle in a few thousand years, and which spill out from whatever settlement they are first took off, in an era where spaceships are easy to make, and where most unclaimed stars are far enough away that nobody from Earth wants to try, but a few of the colonies closer to them have grown enough to want to send their own. But for those first multi-planetary empires, I would guess quite a few of the existing countries around nowadays are still around then, and maybe some of us are still around then too if life extension takes off. Who knows, maybe your homeland will be a multi-planetary empire one day, and maybe you'll be there to see it. We explore the practicality of multi-planetary empires today, but not what they do or who they are. And tomorrow, for April 1st, 2024, no foolin', we'll be releasing our monthly Nebula exclusive, Galactic Beacons, to discuss one such project huge stellar empires might create, and to ask how those would work, what types there are, and why you would or wouldn't make them. And if you haven't already seen it, this month's Nebula exclusive, Crystal Aliens, continues our recent discussions of alternative chemistries for life we had in our episodes ammonia-based and silicon-based life forms. And again, Crystal Aliens is out now exclusively on Nebula, our streaming service, where you can also see every regular episode of SFIA a few days early and ad-free, as well as our other bonus content, including extended editions of mini-episodes and more Nebula exclusives, like last month's episode Tarpopolis, the Eternal River, January's Giant Space Monsters, December's episode The Fermi Paradox, Hermit-Sharpfilter Hypothesis, Ultra-Relativistic Spaceships, Dark Stars at the Beginning of Time, Life as an Asteroid Miner, Nomadic Miners on the Moon, Space Freighters, retrocausality, orc-OR and free will, and more. Nebula has tons of great content from an ever-growing community of creators. Using my link and discount, it's available now for just over $2.50 a month, less than the price of the drink or snack you might have been enjoying during the episode. When you sign up by link, go.nebula.tv/IsaacArthur and use my code IsaacArthur, you not only get access to all the great stuff Nebula offers, like crystal aliens and galactic beacons, you also be directly supporting this show. Again, to see SFIA early, ad-free, and with all the exclusive bonus content, go to go.nebula.tv/IsaacArthur. We'll get to the upcoming episodes in just a moment, but on the topic of things coming up, this year's International Space Development Conference, ISDC 2024, will be in Los Angeles May 23rd to 26th, and it is looking to be an exciting and informative event, including an appearance by William Shatner to receive the Heinlein Award. I'll be there, and if you live in the area, I hope you'll come by and say hi. But if you have some free time then, we always need volunteers, especially to help with the NSS Space Settlement Contest, where we usually have a couple hundred student finalists from around the world giving presentations on their space settlement designs and needing a little shepherding. If you're interested in volunteering, in any capacity, I'll leave a link in the episode description, isdc.nss.org/volunteer-at-ISDC. So that's it for this month, but join us as we start April off on the 4th with discussion of space-based solar power and several other clean energy options from space that might be able to help us power not only our orbital infrastructure, but Earth itself, including options like Earth's own magnetic field. Then on the 7th we'll return to the Fermi Paradox to ask if the reason why we don't see expanding alien civilizations is because they eat their own colonies in the Kronos scenarios. After that we'll have a look at defending Earth, be it from asteroids, aliens, AIs, astronomical explosions, or just mundane human threats, possibly including rebellious space colonies. If you'd like to get alerts when those and other episodes come out, make sure to hit the like, subscribe, and notification buttons. You can also help support the show on Patreon. And if you'd like to donate or help in other ways, you can see those options by visiting our website, isaacarthur.net. You can also catch all of SFIA's episodes early and ad-free on our streaming service Nebula, along with hours of bonus content like Crystal Aliens at go.nebula.tv/IsaacArthur. As always, thanks for watching and have a great week.